learned about dot product of two vectors which give rise to a new scalar quantity. In this class, we will learn about vector product of two vectors which gives rise to a new vector quantity. So let's define it first. Vector product of two vectors is actually a vector whose magnitude is given by the product of the magnitude of two vectors and the sine angle between them. Clear? It gives the magnitude problem. But what about the direction? The direction is defined as the perpendicular direction of the plane containing two vectors. Mathematically, first write down definition of this vector product, that it is defined as a vector whose magnitude is the product of the magnitude of two vectors, and sine of the angle between them. And its direction. Of course, it is a vector, so we should mention the magnitude and as well as the direction is perpendicular. Okay, it is perpendicular to the plane containing the two vectors, and the direction is always determined by right hand rule. I will explain it to you. Right hand rule. Clear? So let's see that the vector product of two vectors is a vector whose magnitude is the product of the magnitude of the two vectors, and its direction is always perpendicular to the plane having that two vectors. Clear? And the direction is determined by the right hand rule. For example, mathematically, let's see. Consider this is a plane. Clear? This is vector A and this is vector B. The angle between them is theta. I have to find A cross B. Okay, A cross B. So its direction, first of all, let's see the magnitude. A cross B, the magnitude will be given by the product of the magnitude of vector A, vector B, and sine of the angle between them. This part gives the magnitude. What about the direction? I already told you the direction will be perpendicular to the plane containing vector A and vector B. So its direction will be perpendicular to the plane containing vector A and vector B. This is represented by n cap. What is n cap? N cap is the unit vector which determines the direction of the cross product of vector A and vector B. Clear? And this is usually determined by right hand rule. How? Use your right hand. See, keep your right hand on the plane, and if I want to find A cross B, then curl your fingers from A cross B and stretch your thumb. The thumb is upward. See, so this is the direction of the new vector. A cross B. Give rise to a new vector C, which is AB sine theta n cap. Clear? So, see that if a plane containing vector A and vector B, the angle between them is theta, and I wish to find A cross B, we know that in A cross B, it is given by AB sin theta. But what about its direction? So simply using your right hand, we will know that this A, put your fingers on this vector and curl in such a way that it rotated from A to B. A to B. Then stretch your thumb out. See, the direction is perpendicular to the plane containing AB, vector A and B. So, for convenience, let us draw like this. This vector is perpendicular to the plane containing vector A, vector B. Clear? So, using your right hand rule, you can find out A cross B and the direction is outward. What if I want to find B crossing? B crossing, the direction is inward and the direction is always perpendicular to the plane containing vector A and vector B. This is very important about vector product. Let's see about the geometrical interpretation of vector product. Consider a parallelogram. Consider a parallelogram P, Q, R, S. Consider a parallelogram PQRS such that PQ represents vector A and PS represents vector B. Clear? PQ represents vector A and PS represents vector B. Do you see? This is the adjacent sides of a parallelogram PQ and PS. The angle between them is theta and angle SPQ is theta. Clear? The angle between vector A and vector B is theta. Let us draw a perpendicular SN on PQ. Let us draw SN perpendicular to PQ. Clear? Now I wish to find out the magnitude of A cross B. Clear? I wish to find out the magnitude of A cross B. You know the magnitude is given by, we know in A cross B we get a vector which have a magnitude as well as direction. If I wish to find out the magnitude of A cross B, I know it is a product of vector A, vector B and sine angle theta. Clear? So here PQ is the magnitude of vector A. For B, PS, and this is sine theta. Clear? Now for better understanding, let us consider triangle SPN. Clear? SPN. We already showed you that this is a perpendicular. In triangle SPN, what is sine theta? In triangle SPN, sine theta is perpendicular by hypotenuse, that is SN by PS, or SN equals to PS sine theta. Clear? We can write SN equals to PS sine theta. Substituting the value of PS sine theta in this, we get A cross B as PQ into SN. Now see, what is this? SN. A cross B is PQ and SN. This is base, this is height. We know in a parallelogram the area is given as base into height. So, we can see PQ is the base of the parallelogram and this is the height. So, I can define more clearly now that the magnitude of vector product of two vectors is actually the area of the parallelogram. It's the area of the parallelogram having two vectors, vector A and vector B as its adjacent side. Clearly, the magnitude of two vectors, the magnitude of cross product of two vectors is actually the area having vector A and vector B or two vectors as its adjacent side. Clear? Now simplifying it, if I want to do A cross B as, if I multiply it 2 and divided by half P Q S N, I just substituted this A cross B and multiplied it 2 and multiplied by half P Q S N. Now define this, half base into height. This is the area of a triangle. Half base into height. This is the area of triangle SPQ. Or moreover, I can write this twice of area of triangle SPQ. Clear? I can also define the magnitude of cross product of two vectors. The magnitude of cross product of two vectors can be defined as twice of the area of the triangle formed by the two vectors as its adjacent side. Clear? Okay, now we will see some physical examples of cross products in physics. First example, which is very important, is torque. Now what is torque? Torque is actually a cross product of two vectors, that is the position vectors and the force vector. Clear? It is the cross product of the position vector of a particle cross and the force vector. Clear? This is a very important example of cross product. Second example is angular momentum. Angular momentum of a particle is defined as the cross product of. Second example is angular momentum equals to the position vector r and the linear momentum of the particle. L is defined as angular momentum. Angular momentum, which is a cross product of, r is the position vector of the particle. Position vector into linear momentum of the particle. Similarly, we will take the third example. Velocity, instantaneous velocity, is the cross product of angular velocity omega and the position vector r. This is velocity equals to angular velocity into position vector. In later classes, you all will know about all these terms and the physical quantities, how they are derived and how they are cross product to each other. Here, these are some physical examples of torque, angular momentum and velocity. Clear? Properties of cross product. Clear? Now let's see cross product. The very first basic property is the cross product of two vectors is anti-commutative. In dot product we learned that it is commutative, that is A dot B equals to B dot A. But in this we will learn that the vector product, or we can say the cross product of two vectors is anti-commutative. That is, we can't say A cross B, we can't say A cross B is equals to B cross A. Clear? We can't say A cross B is equals to B cross A. For example, I already explained it to you that if a plane containing vector A and vector B and the angle between them is theta, and I wish to find the cross product of A cross B, that I have to rotate it from A to B. Clear? A cross B. So I know this is the magnitude is AB sin theta, but what about its direction? Use the right hand rule. Curl the fingers in the direction such as it is rotated from A to B, and you will stretch your thumb out, and you will see the direction is perpendicular to the plane, but it is outward. Clear? But it is outward. If I wish to find B cross A, what about this? If I wish to find about, this is vector A, this is vector B, the angle between them, and I wish to find about the cross product of B cross A. So again, using right hand rule, put your fingers here and curl the fingers in a way that it rotates from B to A, and stretch your thumb. You can see the direction is onward or inward. In this the direction was outward, in this the direction is inward. There is a difference in the direction, they both are in opposite direction. But the main thing is the magnitude will remain same, that is magnitude of A, magnitude of B, sin theta. Clear? In this case also, it will be magnitude of B, magnitude of A, sin theta. But the direction is opposite to each other. Opposite to each other. In the first property you saw that a vector product is anti-commutative. We know that A cross B is not equal to B cross A, or we can write that A cross B is minus of B cross A. What minus sign indicates? It shows that it is in opposite of direction. Suppose A cross B gives a new vector C and B cross A gives a new vector D. Though they are same in magnitude, but they are in opposite in direction. Okay? But they are in opposite in direction. Clear? Now let's go into second property, that vector product is distributive over addition. Over addition. Okay? That is, if I wish to multiply a vector A cross B plus C. See? A cross B plus C. It is distributive over addition. That means it can be multiplied to A cross B plus B cross C. A cross B plus C equals to A cross B, that is A cross B plus A cross C. This shows the vector product is distributive over addition. Let's go into the third property, that vector product of two parallel and anti-parallel vector is a null vector. You all are acquainted with a null vector. I don't say that it is a zero. Zero means scalar quantity. I must say it is a null vector whose magnitude is zero, but it has some direction. Clear? If two vectors are there, vector A and vector B. Clear? And I wish to, and they both are parallel to each other, and I wish to find the vector product of these two vectors. Simply, through the parallel shifting of vector B to vector A, the angle formed between them is 0 degree. Clear? So, we know A cross B is A B sin theta. Clear? If these two vectors are parallel to each other, theta will be 0 degree. What about if it is anti-parallel to each other? If it will be anti-parallel to each other, then of course the theta is 180 degree. So I can write n cap. The direction is important. N cap. AB sin 0 degree or 180 degree. N cap. We know this is 0 vector. AB sin 0 or 180 degree except this will give to a null vector. Null vector means the magnitude will be 0, but there must be a direction which is determined by the unit vector. Clear? Now let's see the fourth property, that That is the vector product of a vector to itself gives a null vector. Say that if I wish to multiply vector A to the same vector A, that is the angle between them is 0 degree, that is the magnitude A of vector A and the magnitude of vector A sine 0 degree and cap. This will also give rise to a null vector. Clear? That is magnitude of two mutually perpendicular vectors. Mutually perpendicular vectors, magnitude of two mutually perpendicular vectors, then the cross product is the product of their magnitudes. That is, if I wish to find A cross B, A vector and B vector are magnitude of vector product of two mutually perpendicular vectors is the product of their magnitude. Suppose vector A is perpendicular to vector B and I wish to find A cross B. Magnitude, the magnitude of A cross B. This will be A, B sine. I already told you that vector A is perpendicular to vector B. So the angle between them is 90 degree. So it will be simply the product of their magnitude. Clear? And the direction will be also perpendicular to the plane containing vector A and vector B. Clear? So if two vectors are perpendicular to each other, then the magnitude is always the product of their magnitude of the two vectors. Clear? Let's go to the sixth. That shows the vector product of base vector or orthogonal vectors. That is I cap, J cap and K cap. Okay, the seventh property of vector product is vector product of orthogonal unit vector. You all have a great idea about orthogonal unit vectors. That consider Cartesian coordinate. This is x-axis, y-axis and z-axis. The unit vector along and these all are mutually perpendicular to each other. The unit vector along x-axis we know this is I cap. Along y-axis we know it is J cap and along z-axis we know it is K cap. They all are mutually perpendicular to each other. What if I want to find the cross product between I cap and J cap, or J cap into cross K cap, or K cap cross I cap? So let's just find out the cross product between I cap cross J cap. It is a unit vector, so remember its magnitude will always be 1. And the direction is always perpendicular to the plane. So we know the unit vector I cap into J cap, the magnitude is 1. For J also it is 1. For angle sine theta is 90 degree and n cap. So of course it is 1 into 1 into 1 is n cap. So I cap cross J cap gives the unit vector n cap. We know this n cap is perpendicular to the plane containing I cap and J cap. So which vector is perpendicular to I cap and J cap? Of course K cap. N cap is nothing but the unit vector which is perpendicular to I cap cross k cap. Similarly, I can write down. If I wish to find j cross k, j cap cross k cap, I know it is also 1. The magnitude of unit vector j is 1. For k it is 1, and the angle between them is cos 90 degree, sin 90, and direction is n cap. So it is 1 into n cap equals to n cap. Again, for j cross k, the answer is unit vector n cap. So which vector is perpendicular to j cross it? It is I cap. So I can write j cap cross k cap equals to j cross k cap equals to I cap. Clear? So let us define I cross j equals to k cap, j cross k equals to I cap. Similarly, k cross I equals to j cap. In this case, they all are, the angle between them is 90 degree. The angle between j cap and k cap is 90 degree. The angle between k cap and I cap is 90 degree. What if I want to find I cross into I cross? We already know it will give it to a null vector 0. Okay? I cap cross I cap is 0 vector. J cap cross j cap is null vector. K cap cross k cap is null vector. Yeah? An important thing arises in it. We know I cross j is k cap. What about j cross I? I already told you that a cross b is not equal to b cross a. They are anti-commutative. The magnitude may be same, but the direction is always opposite to each other. So let's see this in a cyclic manner. Okay? Consider a cycle. This is I cap, this is j cap, and this is k cap. Clear? I wish to find I cross j, and I know I cross j gives to a positive value of k cap. Clear? I wish to find j cross k. I know j cross k will give the positive value of I cap. See how I am going in a cyclic manner anti-clockwise. What about k cross I? It will give back to j cap. K cross I cap gives back to j cap. We get positive value anti-clockwise. What if I have gone in a clockwise direction? Similarly, again I am writing this I cap, j cap, k cap. Clear? What if I already did I cross j? See, I cross j. We know I cross k cap. I cross k cap will give us minus j cap. Okay, I cross k cap will give minus j cap. K cap cross j cap, it will give rise to minus I cap. What if j cross I, j cap cross I cap, it will give rise to minus j cap. This is the in negative values when I put them in clockwise direction. Okay, always remember I cross j give rise to k cap, j cross k give rise to I cap, and k cross I give rise to j cap taken in anti-clockwise sense. What about if I take in clockwise? I already told you that vector product is anti-commutative. Of course, I cross k will give rise to minus of j cap. The magnitude will remain same, but the direction is opposite. K cross into j cap equals to minus I cap. J cap cross I cap equals to minus k cap. Clear? So, another property, that is find angle between the two vectors. We know the magnitude of the vector product of two vectors A cross B. Magnitude is given by vector A magnitude, vector B magnitude and sine theta. The product of vector A magnitude, product of vector B magnitude and sine theta. So here we can find sine theta is magnitude of vector product of A cross B divided by magnitude of vector A to magnitude of vector B. This is how we find the sine theta between the two vectors of having cross product between them. Let us find out another property, that is unit vector. Unit vector n here in the cross product of two vectors. We know the cross product of two vectors A cross B gives magnitude of vector A, product of magnitude of vector A, vector B, sine theta. This is the magnitude part, and you can this is the direction part. Or else I can write down vector A cross vector B. This is the magnitude part. I can write down like this: A cross B magnitude into n cap. So now n cap equals to A cross B divided by magnitude of A cross B. This is how we find out the unit vector of two vectors in cross product. Clear? Now we will study about vector product in terms of rectangular components. We can express vector A and vector B as their rectangular components and wish to find the vector product between them and see the results. So let us start. Let us write vector A in terms of the rectangular component. We know it is AX I cap plus AY J cap plus AZ K cap. I have expressed vector A in the rectangular components as well as also vector B in the rectangular components as well as Bx I cap plus By J cap plus Bz K cap. Now we will find the vector product of vector A cross vector B in terms of their rectangular components. Clear? So let us start. Vector A cross vector B equals to, in terms of rectangular component, Ax I cap plus Ay J cap plus Az K cap cross Bx I cap plus By J cap plus Bz K cap. Clear? Let us start by doing one by one. Now Ax I cap cross this bracket Bx I cap plus By J cap plus Bz K cap. Clear? Again plus Ay J cap cross again Bx I cap plus By J cap plus Bz K cap. And finally Az K cap cross Bx I cap plus By J cap plus Bz K cap. Now let's start solving one by one. That's it. See, Ax, Bx, these are the magnitude part. So they can be multiplied directly. Ax, Bx, I cap cross I cap, I cap cross I cap. Clear? Again plus, since it is distributed in nature, again Ax into By. These are the magnitude. And unit vectors I cap cross J cap. Clear? Again last ax multiplied by bz, and in bracket I cap cross k cap. Clear? One bracket is completed. Next, ay bx j cap cross I cap plus ay by j cap cross j cap plus ay into bz and j cap cross k cap. Again, now let us solve the last bracket. Az bx k cap cross I cap plus az by k cap cross j cap. Lastly, az dot bz, az multiplied by bz, k cap cross k cap. Clear? In this, we can clearly see that these are the magnitude part and these are the unit vectors which are multiplied with another unit vector. So we will use the property over here. I cap cross I cap, these are the same unit vectors. We know when same unit vectors are cross product, when they are under operation of cross product, they give a null vector. Similarly, I vector cross j vector. Okay, see in the anti-clockwise direction, I cap cross j cap, they will give rise to another unit vector which is perpendicular to this. The cross product of this two unit vector is k cap. Now I cap cross k cap, this is in the clockwise direction. I cap cross k cap, this will give rise to j cap but in opposite direction. So we will use minus j cap. So one by one we will determine the values of the cross products. Clear? So let us continue solving. Now ax bx I cap cross I cap, we know it is a net vector 0. Clear? Plus ax by I cross j will give us to k cap. Clear? Next, ax into bz I cap cross k cap give us to j cap but in opposite direction. If you want to see like this, see I cap j cap k cap. I already told you in anti-clockwise it is like this is positive and clockwise it is negative. See, I cap cross j cap, I cap cross j cap gives us to k cap. Again, I cap cross k cap gives us to minus j cap. Similarly, again a y bx j cap cross I cap, j cap cross I cap. It is again in clockwise direction. It is minus k cap plus ay bx j cap cross I cap, j cap cross I cap. Actually, I have already done it. Sorry. Ay into bx. Again, ay by j cap cross j cap is a null vector. Ay bz j cap cross k cap, j cap cross k cap will give us to I cap plus az bx k cap cross I cap will give us to j cap plus az by k cap cross j cap. See, it is in clockwise direction. It will give minus I cap plus az bz k cap cross k cap is again another vector. Clear? Now we will start taking j cap and k cap. Now let us continue solving a cross b. We know, see, ax, bx, 0, this term got cancelled. Again, ay, by, the 0 vector, this term again got cancelled. And az, bz, 0 vector, this term again got cancelled. Now the remaining terms, ax, by, k cap, ax, bz minus j cap, we will try to rearrange all this. Clear? So first write down I cap. Clear? We will see the I cap terms. Taking I cap common out of the expression, this is ay, bz. Again, if I find out, this is I cap minus az, by. Clear? Again, the I cap term is completed. Now, we will go for j cap. This is minus j cap. Okay, no problem. We will take minus j cap. Ax, bz. Now, this is plus ax, bz plus az, bx. So, I can write like this. Ax, bz. The j cap term is completed. Now the remaining is k cap term. Plus the k cap term, we got k cap, and the remaining terms are here ax, by, and the remaining here this minus ay, bx. Clear? Now so we see that the vector product of two vectors a cross b in terms of rectangular component can be precisely written as I cap a by bz minus az by minus j cap ax bz minus az bx plus k cap ax by minus by bx. More precisely, we can write it in terms of determinant form. That is, a cross b can be written in terms of determinant that we know is I cap, j cap, k cap. More precisely, we can write, or for convenience, we can give the sign convention. We know it is for I cap it is ax, for j cap it is a1, and for k cap it is az. Similarly for b, it is bx, by, and z. Yeah, then how to solve this in determinant form? See, when we are solving for the I cap component, neglect the row and column. Okay? Then the remaining will be, this is the row and column, the remaining will be I cap, then ay into bz minus az into by. Okay? For I cap, neglect the column and the row. Now just see the remaining 4 will be multiplied ay bz minus az by. Again, for minus j, we are getting the same results. Neglecting this row, this column and this row, we get the remaining 4 ax, az, bx, bz. So similarly, this can be again written as ax into bz. Don't take the middle column. Ax, bz minus az, bx minus az, bx. Again, lastly, for k cap, neglect this row, this column and this row. We got this 4 remaining. So this will be ax, by minus ay, bx. See, we got the same result. So the rectangular component of a cross b, and if we want to cross product it, we can directly write it is in the form of determinant form. Clear? Thank you.